We will talk today about work intelligence. Why are incidents happen? And what can we do about them? What can we do to solve this issue? Today, 7 out of 10 incidents start with a person. And I have good news. Now there is a solution. Now let's put some numbers behind it. If you take an average offshore facility, 104,000 approximately on average per day lost because of unplanned downtime. That's a big number. If you scale it to the year, 38 million. If you count fatalities, 32 industry fatalities here in the US 2024. If you scale it on the wild perspective and take all the dangerous jobs, you talk about 1,000 deaths a day. Now, why is that? Here's the good news in one way, that we can do something about it. 70% of the accidents trace to a human or organizational cause, not the machine. And if you break that problem down, it's actually not one problem, it is 7. Now, let me talk about those 7. The most normal one is that procedure was never practiced. The crew was doing this procedure for the first time. That happens in oil and gas, that happens in mining and many other areas. For that, we'll talk today about how we can address it by having a simulator called Genesis that practiced the exact procedure on a twin of that plant. Very similar that we do for aircrafts with aircraft simulators. The other issue is that we lose experience constantly. The person who knew how to fix that particular issue retired in March. The way we address that is by having something that captures that knowledge before it leaves. We call it EON Tacit. They capture what they know, they check it, and they let any worker get access to that information instantly. The third issue is when things go wrong. So you practice for the perfect situation or ideal scenario, but you haven't practiced for the bad day. And that's what we can do by rehearsing things when things go wrong. And we can do that in something we call EON Life. It has real physics. And if you turn the wrong knob, it will react as it reacts in reality. And we can encapsulate that in something we call the situation room that has real accidents that have happened, and where we can bring back the time so the team is in the room and can try to manage and learn from that issue and corrective measures. Last, we also want to talk about told but not tested. So let's say you told through learning, LMS and others, how to conduct this procedure, but you didn't have the capability to verify hands-on that actually they can do it. There's a solution for that where you prove in a simulator that you can do it, and you assess and verify the competence. You get the valid score of the work you performed, and you do it in a way that the regulator can accept it. There are a few others, very quickly. One is that the plan didn't match the job. So many times before you touch the physical environment, you have to do a plan and to get a permit. Now, many times, this permit that you created didn't cover the actual work. So you have a theory of what you're going to do, and that's not matching the reality. Now, how do we know that? Because many times in the moment, you're about to do something and you don't have the guidance and you skip a step, or you are doing it on the wrong asset. We prevent that by guiding and assisting you in the moment of work. We have something called Field IQ and Edge that provides you through a tablet, through air glasses, guidance and assistance on the job. Finally, this is very common when you look at investigations. You find again and again the same mistake occur. So this happened before, and unfortunately nothing changed, so it happened again. We circumvent that and address that by having a system that learns. We call it Compound IQ and The Distillery. And what it does, it takes the data from the field that it learned, even the edge cases, and goes back into the tween where the procedure, and we call it the work intelligence flywheel, it gets better and better and better from these lessons learned. So, now, a scary statistic, if you go even deeper and look at why people die, for example, in oil and gas, you can see a number of things that reflect what we just said. 90% of the cases, the crew never seen the plant. 53% nobody was next who has done it, etc., etc. So this is, if you're interested in statistics, there's a lot of safety and ergonomics around this that can prove which cases occur mostly. So how is EON addressing these issues? We try to keep it simple. It's one single platform and two products. The first product is the digital twin that builds the twin of your facility. The second one is the work loop that guides and captures every job. So the way the flywheel works is that you take the digital twin with the approved work and you utilize that during the work loop, and that then the lessons learned from that comes back as verified learner, and the twin gives work context, and that makes the work smarter and the twin smarter the more you use it. Very much the same as a Tesla learns from actual driving, where the edge cases are captured, and the day after all the cars get that extra knowledge that one car has learned. So the modules that you see within each product are the ones that address different issues. EON Universal can take a picture of an environment or a plant and convert it to a 3D model. Genesis takes that model and applies the standard operation procedure and designs the scored simulator. EON Live does the same, but now with live physics. The situation room compounds this, but focus on major incidents, what caused them and how can we prevent them. EON Tacit, I already talked about that, preserves the expert knowledge. And on the working loop, you have Permit IQ that digitalizes the plan, Field IQ that guides and assists you on the job, Assess IQ that scores how well you did, and Compound IQ that provides you the durable knowledge. And finally, we take that knowledge and distill it, so we feed the intelligence back to the digital twin. So a little bit repetitive, but that gives you the big picture. Now, very important here is the knowledge that we aggregate stays yours. We call it customer intelligence, always owned by you, never leaves. So the SOP, the digital twins, the maintenance history, all that is yours. The work intelligence is the failure patterns, the engineering principles. This is something that EON has developed, as well as the machinery that captures this. So we give that work intelligence to you, royalty-free, and the more we learn, and the more you provide you that knowledge. Okay, so this presentation is not only about theory, it's about show me. So you heard the theory, every slide that follows launches a software. Intentionally, I'm not going to do a full demo. I'm going to present just the highlights. And if you're interested, we can do a deep dive at a later stage. But I want you to get your flavor of these products. So the way we organize them is in three groups. One we call the foundation. This is what you need to build anything. So what is that? You need to be able to practice, you need to be able to turn the SOPs in simulator, and you need to be able to create those twins from photos. That's the foundation. Then you have the judgment. Before you start the job, you need to capture as much knowledge as you can. You need to rehearse bad things going wrong, and you need to have the digitalized permits. So that's step two. And finally, while the job it happened, and after that, you need to be able to prove that you can do it. You need to be able to guide people and have the system that learns. So that's the progression in terms of modules. Let's start with the first one.
Wear your hard hat, safety glasses, gloves, and other required PPE to keep yourself safe before starting any work on the system. Check that P102A is running properly and the level control is stable, since this is vital for preventing any level alarms during the changeover. Opening V1201B, the standby pump suction valve, fully is essential for a smooth changeover, ensuring the pump can operate properly when needed. Open the casing vent on DV20110 just enough to see continuous liquid, then close it to prime the standby pump. P102B is your standby pump. First, make sure the discharge valve is closed before you start it up for safe operation.
Okay, so now you can see that I was in control here.
Slowly open the standby discharge valve and keep an eye on the flow and discharge pressure. This is crucial to ensure everything is working as it should.
Okay, so I will not do the demo myself for the next step. This is something you can do yourself, or I'll attach a video how these things were created. Okay, so let's go to next. Now, to have all that, we need to have a library. So we have a vast library, actually the world's largest in this field, that covers more than 8,000 components, oil and gas components, mining, medical, and many others. And I can pick any component. Let's take one here. Let's take this one. And I can see it, how it works. I can X-ray it. I can, of course, rotate. I can label the components, get the X-ray back, turn off the labels, see the flow related to this. If not, understand more about, play a tour and how this works. I can also stop that and stop rotation, look at the parts here, and close it and run a procedure. For example, operation.
Verify line conditions match the valve's intended service before operating. Open or close the valve slowly using the hand wheel or actuator to avoid water hammer. It's the hand wheel. Catching abnormal vibration, leakage, or heat early prevents a much bigger failure.
So this is the building blocks that are then utilized when you want to build something from scratch, right? You have various components. So that is a part of Universal. We also have a part where you can simply take pictures and then convert those pictures into a full plant. The next thing is two things here. There's something called EON Tacit, and that's the lost experience. I'm not going to go into that. We have the permit, but I want to go to something called EON Live. This is pretty exciting. So now the difference is that instead of having the perfect situation, you can actually simulate what happens if it goes wrong, because this has real physics engines. So let me show you what I mean.
4 kinds of energy are live here. This machine holds 4 kinds of energy. The motor is live electrical power. The pipes and vessels are full of gas under high pressure. The compressor runs hot.
Okay, so I can stop that, and I can, if I want to understand what drives this, you can see, for example, heat.
Hot gas and hot metal can burn you. Squeeze a gas and it gets hot, like a bicycle pump getting warm. The compressor packs the gas tighter, so its temperature climbs to about 78 degrees.
I can see what a surge means.
Surge can wreck a compressor in seconds. Starve it of flow and it coughs the gas backwards, violently. You must remove the trapped energy before opening. Let the gas out to the flare, like deflating a balloon. The vessel bleeds. The machine is not instantly safe when you hit stop. Cut the power and it keeps spinning, like a bike wheel. The shake tells you if it is healthy or sick. Hot metal still burns after power and gas are gone. It cools slowly on its own, like a kettle.
So you can see, you can explain it, and then you can go through a process. And
running with surge margin to spare. A compressor lives on a curve, head against flow.
So that enables you to then create a numerous applications, and I'll show you just one or two. We have something called a situation room. These are real accidents that actually happened, and we drive them with EON Live, what you just saw here. So for example, if I take oil and gas, and if I put here, let's listen in, you can see that we have the deadliest accident. And now with that in hand, you see the deadliest accidents, you see the most frequent ones, and as I'm holding my thumb, you can actually see an enactment of those accidents. You see the top picks for you. You see flagship disasters. If I pick one, for example, heat exchanger, for that I will be able to see a live simulation. I can ask Brainy about this particular situation here. I can talk with Wayne. Wayne is one of the specialists that has been there, seen this.
Hi, I'm Wayne, and welcome to the Situation Room. This lesson is about heat exchanger, reactor cold restart transient. Together, we'll learn to recognize the warning signs, understand what can go wrong, and act before the situation escalates. Are you ready to begin?
Yes. Give me the 30-second dum-dum version.
A cold restart can rupture HTHA weakened equipment. Check condition records first, ramp in stages, hold on abnormal readings, and escalate.
Obviously, this discussion can proceed for a long time. You have course material that is used behind it based on the real accident that happened. You have the XR experience. You can see different experiences. You have MCQ, multiple choice question. You have an oral interview. You have eventually a certificate that, assuming you pass all those tests, you get. You can also see the control sequence, how often this happened. You can see in 2016 there were 941 records in 30 new failures below the carbon steel curve. And what was the consequence? 7 people were killed. So these are real situations that we are having in this room. Now you can build your customized situation room as you use this. So this is about judgment. Keep in mind, I haven't entered the Tacit. Tacit itself is very interesting. If time allows, I would go. So you can see here, there is literally more than 1,450 interviews here that are captured. Let's see here, if I get to Interview Studio, you can see here you can conduct interview. You have expert memory. Let me just make it a little bit bigger so you can see it. Let's pick one. You can select here, for example, Owen Briggs, and you can see his interviews. And you can play that interview.
It's never the meter reading, if I'm honest. It's the quiet after somebody goes down. Picture a vessel that's been purred.
So what happens is these are interviews. We dissect what's facts from what's kind of drama or colorful, and that brain extraction is then combined in a body of knowledge that then is distilled and utilized to help workers in the field when they need that 30 years experience. Permit IQ, similarly to this, it helps people to fill in the necessary forms, make sure that they then match what happens in the field. So this will require a longer time for me to go through. Likewise, field IQ, edge, compound IQ. But interest of your time, I'm not going to do that right now. So how do we work? We start always with the foundation, which is $250,000. Full price is $300,000, but you get it for $250,000. Now, that means that you can actually run multiple simulators, things that will cost you literally millions of dollars, and we'll, of course, help you to build the first ones, and then you can do as many as you want. The intro offer here that we have is a special offer. We call it the Master Key, and it's something where in your region we have 12 master keys. Already 9 of them have been distributed. So the idea is that you pay only for one of these three packages, and then you can get access to all three until the end of the year. So the idea with that is that you should try and see the benefit of both foundation, judgment, and full loop without having to pay for that. So that's something you can take advantage should you be interested. Now, in conclusion, what we have here is one plant, one system. And while we were talking, it got just smarter. So next step, if you are interested in this, we can work with you. You send us a procedure, P&ID, a set of photographs, and then we can build it. And you can see that. Keep in mind that if you are taking advantage of this master keys, there's 3 of 12 that remain. Okay? There's a lot of other information that, in interest of your time, we're not going to cover right now. But if you're interested in that, sources, how EON works versus the competition, why we are so unique, and the largest companies on earth in oil and gas have exclusively selected us. Also, how these software work in a control panel environment, etc., etc. But I want to thank you for your interest and looking forward to the next step, and looking forward to receive some information from you that we can process. Thank you so much, and talk to you soon.